Now let's investigate the isospin flavor and the color charge. So isospin first. Now the isospin on the higher generation quarks is predicted by the standard model to be 0. So here we have the generic quark and D quark, and we have an isospin of -1,6 minus plus minus -1,6, which is -3,6, which is -1/2. And we see on this boson 0, we have opposite isospin quanta, but if we look over here on this boson 0 with the flavored anti-V, we will see that we have a 1/3 and a 5/6. So 5/6 take away 2/6 leaves 3/6. So we have a positive 1/6, which cancels this negative 1/6 over here. And so we begin on the B quark with the appropriate isospin of 0. Now let's go and look at the C quark. And we see on the C quark we have the -1/2 that we initially had on the generic D quark, but on the boson plus we now have a +1 made of 1/3 plus 1/6 is 3/6, which is 1/2. So the 1/2 cancels the -1/2, and we have a 0 isospin as predicted by the standard model. And of course we have the corresponding opposite isospin quanta on the anti-B. But let's look at the W minus. The particle, the T anti-T particle pair has opposite isospin, so it's 0. And then on the boson minus, we actually have -1/3 or 2/6 and another 1/6, which gives us -3/6, which is -1/2 for the isospin on. But we must look and see that this boson 0 is not included in the C quark, so will be included in the boson minus, and this +1/2 will then negate this -1/2, and so on the W boson minus we will likewise have a 0 spin. Not a 0 spin, but a 0 isospin as predicted by the standard model. And so we can look at flavor. And the flavor on the B quark is given by this boson 0, which has the flavored anti-V, and it is -1. And then we look at the C quark, and the flavor is given by this V flavored rishon, and it has a 1, and that is the appropriate flavor for the C quark. Now, we can see that on the W we actually have this -1, and we also have this -1, and so we actually have -2 flavor being carried away by the W boson. And if we look here though, we have this neutral boson actually negating with this neutral boson and canceling the flavor charges for those bosons, leaving only the flavor charge of -1 on the anti-C quark, which is the predicted flavor charge for an anti-C quark. So now, color charge. The color charge will be represented by the right-hand section of the semicircle. As we can see here, we have purple and yellow, which cancel each other out, and you can see the quantum numbers are displayed when you hover over the Rishon. And so we end up with a red half of the semicircle on this anti-V Rishon, and so the color charge of the B quark is red because the color charges on the boson zeros all cancel. And if we look here, we still have a purple charge indicated on the right hand side of the semicircle and a yellow, so those cancel, and we still have the red charge on this generic D, and since the color charges here, a blue and an orange, cancel, we have the correct color charge of red being preserved in this decay. And we look at the components of the W boson, and we see particle-antiparticle of purple and yellow canceling. We see orange and blue canceling here, orange and blue canceling here, and last but not least, we have this red and green as a component of the W particle, which also cancels. And then we look at the anti-B, and we will see that we have again yellow and purple canceling one out, giving us the anti-color of the red-green. And then we have blue and orange canceling, and we have green and red canceling. So the initial color of the B quark was green. And this one, when it transforms into a C quark, will cancel with this neutral boson, and this neutral boson will cancel with this neutral boson, leaving only this neutral boson here with no color charge. So the color charge will again on the anti-C quark be anti-red or green. And there we have the analysis of the quanta in the decay products of the B quark.